Okay, let's go ahead and fill in our heading, name, number, date, first and last in cursive. Remember to put the date that you are working on these notes, not necessarily the date I'm writing. Our subject is math. All right, so we're going to look at those cubes, circle our numbers, underline our question, box keywords, eliminate unnecessary information, and solve. That's our annotating for our word problems. A small sofa has a mass of 30 kilograms. A pillow on the sofa has a mass of 300 grams. How many pillows would it take to equal the mass of the sofa? So we want to see how much it would take to equal it. So we know the total is 30 grams. I'm sorry, kilograms. That's our total. When we know the total, we're going to either subtract or divide. Are each pillow the same amount of mass? Yes, they are. So when we are dividing, when we're making equal groups, we divide. So we're going to be dividing. Problem is, we're not in the same unit of measure, so we need to change one to the other. 1 kilogram is equal to 1,000 grams. So first, I need to convert those kilograms into grams. To convert from larger to smaller, I multiply because there are more of the smaller units in there. So 30 times 1,000, well, I have 1, 2, 3, 4 placeholders. So it's going to move it over 4 places. Each time you multiply by a multiple of 10, it moves it over a place. 3 times 1 is 3. So we get 30,000. And we're going to divide 30,000 by 300. Well, I already have 2 placeholders here. What would I have to multiply by to get 1, 2, 3, 4 of them? Well, I have 2. I need to multiply by something that has 2 placeholders. So it will move it over 2 places. And to get 3, I would multiply by 1. 100 times 300. 1, 2, 3, 4 placeholders. 1 times 3 is 3. Number's the same. Zero's the game. So that means for them to weigh the same amount, I would need 100 pillows that would have the same mass as the sofa. That's a lot of pillows. It takes 100 sofa pillows to equal the mass of the sofa. Right. Next problem. Colin weighs 9 times. So when I see the word times, I'm either going to multiply or divide. Depends on whose weight we're told. If we're told Colin's, we're going to divide. If we're told the other person's, then we're going to multiply. Colin weighs 9 times as much as his baby sister. Colin weighs 63 pounds. How much does his baby sister weigh? So we're looking for the baby sister. We know his total. We do know the total is 63 pounds. So we're going to either subtract or divide. Well, since we have the word times, that tells me I'm going to ultimately divide. because what we're looking at here is that Colin, his weight is 9 times the baby. So this as an equation, Colin is 9 times the baby. And we know that Colin is 63 pounds. Well, what would the baby have to be for this statement to be true? What times 9 is 63? Well, using that inverse operation, this is where that division comes in, because we know the larger units. So we're dividing. 63 divided, I don't know why I've made that a 6. It's a B. 63 divided by 9 is 7. So his baby sister weighs 7 pounds. She must be a newborn. Colin's baby sister weighs 7 pounds. Okay, our next problem. An elephant weighs 3 tons. How many pounds does the elephant weigh? Okay, so we're just converting here. We're converting from tons to pounds. Well, 1 ton equals 2,000 pounds. So to figure out what 3 tons is, to go from larger to smaller units, I multiply because there are more of the smaller units inside that larger unit. 3 times 2,000, I have 1, 2, 3 placeholders. And 3 times 2 is 6. So that's all we had to do, is to change it from tons to pounds. Not too bad. The elephant weighs 6,000 pounds. Here's our last problem. David's backpack weighs 8 pounds with all of his supplies. If he takes out 5 notebooks weighing 5 ounces each, how much will his backpack weigh? We have a couple of steps here, because we have to figure out one of these. We need to change either this to pounds or this to ounces. We need to do some multiplying to figure out our total weight. And then we need to subtract it from the weight of the backpack, because if we're taking it out, we're subtracting. So we have a few steps here. So 1 pound is 16 ounces. So my step 1, I'm going to convert those 8 pounds to ounces. So I need to multiply the two. So I have the same units. And right now we're converting to smaller units. 8 times 6 is 48. 8 times 10 is 8 tenths, plus 4 more tens is 12 tenths. So this is what the backpack weighs in ounces. 128 ounces. So that's how much the backpack weighs. Step 2, I need to figure out what all 5 notebooks weigh. Well, they all weigh the same. They all weigh 5, and there are 5 of them. So we're joining together equal amounts. We can multiply. 5 times 5 is 25 ounces. Now step 3. This is a 3-step problem. I need to take those notebooks out of that backpack. I'm going to take that 25 out of the 28. More on top, no need to stop. Numbers the same, zeros a game. More on top, no need to stop. So that means the backpack is left weighing 103 ounces. Now it doesn't say it had to have the answer in a certain unit, so I can leave it as ounces. It doesn't say it wants it in pounds. The backpack weighs 103 ounces. All right, now that we've practiced these word problems involving masses of objects, let's go ahead and practice some more on your own. Thank you for joining me.